Då är ni välkomna till Borås. Då är det vår sista dag på Innovationsveckan som vi ska ha seminarier. Idag har vi 4 seminarier, 3 på förmiddagen och vi avslutar med rekoringen lite senare i eftermiddag. Där ni också får vara med vid en utlämning där man då lämnar ut varor i sina bilar. Men först ut idag är det mellan 9 och 9:45. Innovativ textildesign från Borås till Hollywoodfilm, det är ni. Det är McMQuillan, Karin Peterson och Kathryn som ska prata och this is in English, yes. So, very welcome and shoot.
Thank you. Hi everyone. So we're here to talk to you today about a project that we've been collaborating on for a while. It's kind of in the field of molded woven textile forms. I'm McMQuillan, Karin Peterson and Kathryn and we're part of a research collaboration called Critical Textile Topologies, which we founded recently. This is our website, so if anyone's interested, go and have a look. We're a collective of European designers and researchers exploring new textile expressions, processes and methods for critical understandings of textile forms through the questioning of what materials, textiles and form are. A range of methodologies are explored, from design for additive manufacturing for non-woven garments, whole garment weaving, the use of smart textiles and form production processes, emergent textiles, and the development of on-demand yarn for textile form production. In a future perspective, the methods can enable the development of new regenerative microsystems for a range of textile-based outcomes. Our research interests in general include things like textile futures, speculative design, design for textile forms or whole garment weaving, material exploration, digital 3D design, transition design, design methodologies, and design for cyclability. This is us. You can see the 3 of us up there as well. And so we come from a range of countries. I'm from New Zealand originally, as is Kathryn. And we have people originally from Finland, Spain, the UK, Netherlands,
Sweden.
Sweden. And these 4 here, so me, Karin, Kathryn and Rika, currently PhD students at the Swedish School of Textiles. So the interesting thing about that we've found in working together, being PhD students, working together in a studio, is that there's sort of certain conditions that have led to innovation in this context. We're all design PhD students, artistic research PhD students, and so experimental design research is kind of core to everything that we do. And so that there's a huge amount of support for us to test innovative ideas very freely. There's a very collaborative environment between PhD students, and we have very distinct and separate but overlapping fields of interest. So my PhD explores woven textile forms, so 3D woven garments. So I'm working in the space between form design and textile design. Kathryn?
My PhD research looks at smart textile design, particularly at how we can do non-electronic smart textiles, looking at the emergent behaviour that arises out of the fibre yarn weave system.
And I work with a sort of form thinking. How can we think form giving and crafting of surfaces as a simultaneous action in dress? And I work obviously woven when we do collaborative work, but when it's my own practice, I work with non-wovens, so moulding non-wovens, basically. And I also had a little thing I was going to say, that if you have any questions in regards to what we're talking about here, you can email in, and we'll do it in real time, so to speak. And the email is Carola, with a C, .Samuelsson, with 2 S's, at boras.se.
And one of the other things that's been really valuable for us in terms of this collaboration and sort of conditions for innovation has been facilities, both access and opportunity to use them. The facilities here are from my perspective, some of the best in the world. And the first time I came to this university, I was pretty gobsmacked. So now we're going to talk about what started this collaborative project, and so we're kind of, I've been calling it Experiment Zero. It was kind of like the very, very starting point of this. And what you can see on the slide is a part of the development process and the progression from the form-giving process, which Karin does using materials like clay, sometimes glass and that kind of thing, and this very analog moulding process, and then we scan that and can import it into digital 3D software called Flow3D. And then there's a flattening process, trying to work out how to weave or flatten this 3D form into something that can be woven on a loom, and that might include like paper models and that kind of thing. And then you end up with a pattern that you can turn into what we call a map of bindings. You program that map of bindings with particular bindings.
Yeah, I'll talk a bit about that. So the map of bindings is analogous to the artwork that's used in web design, but it has a lot to do with layers. So in order to make these garments able to fold out in reverse origami, essentially you take a rectangle and then some certain cuts and you can unfold a garment out of it. And so it's all about the layers and how the layers interact. And so programming those bindings is really important. And that all comes from the map of bindings, which is derived from the pattern. So there's this loop of kind of design where everything happens all at once. And that's kind of really key to this process. It's not a linear process, it's very much cyclical. Everything is happening at once. The textile and the garment are the same thing.
Yeah, and that's why I call it textile form, because it's not a separate thing. It's not textile design and then form design. It's kind of all tied up together in one process. And then the other, so what you can see on the slides here are the first experiment being woven on the loom, and then it's been cut, so the layers have been separated, and then the last two images on the slide show a special binding that was developed between me and Kathryn that enables this kind of expansion and change over time element. Also embedded in there is NSK yarn, which shrinks with heat.
Yeah. Heat shrinkable yarn.
Yeah. So this is the next stage in the process, which Karin can talk about a little bit.
Yep. So you see up there, it's a mould, and the mould is identical to the little crafted clay form in the beginning. And this mould is, as you can see, scale 1:1, and you can actually use it as a restriction and to shrink things on. So in this case, the original form has informed the weave, and then when we sort of unpack the layers, you can either just call it a garment there and then, or you can also shrink it or activate the form on top of this mould.
Yeah, that's what you can see
what we're doing there. So then it will sort of, where we program it to shrink, it will shrink, to even further take the form of the initial form, so to speak. There's a lot of form, but yeah.
And so you can see here, these are all the same garment and same textile. There's no extra sewing or extra construction that's occurred. The only difference is the heat applied. And so the first form and the last are the same on the same person. And in the middle is it being shrunk on the mould that Karin's CNC cut at 1:1 scale.
This shrinking process is kind of really crucial to the outcome of the aesthetics, because as it shrinks, the fabric surface deforms, and so you get this texture that occurs in the two examples where it's been shrunk that doesn't exist, and it would be impossible to get through conventional cut and sew methods, or very difficult, very time consuming, and it happens as part of the process.
We also experimented with not using the mould at the final stage and just shrinking the entire thing evenly. So I put it in a dryer, and you can see the texture that comes out of that in these close-up shots. And again, this is exactly the same. The form of it is significantly more tight-fitting. It looks like a completely different garment, but it's exactly the same. And the benefits of this, I guess, are that you can shrink it to fit a person. It can be like as your body changes over time, you can change it so that it adjusts its size relative to you, or maybe as style changes or fashions change. So now we're going to talk about this project where we applied this in the context of a film which was. We were approached by Liam Young, who's a director of Planet City, which has been shown at the Melbourne Triennial at the end of this year. And so it's a film, it's a book, and an exhibition. And he asked us to produce some costumes for it using this process for a city concept where the entire population of Earth, this is the concept of the film. The entire population of Earth is contained in a single super city, where all of the resources required are produced within that city, using approaches such as vertical farming and the remining of waste from late capitalism. So it's a very futuristic kind of film, and so we decided that we would develop a fully circular, zero waste, on-demand concept that responded to that. The collaboration was kind of in three parts. There was the Planet City commissioning group, which was the director, Liam Young, costume director, Anne Crabtree, who was the costume designer for Handmaid's Tale, us as Critical Textile Topologies research group, and then we had some suppliers, so we used the Dutch weaving company EE Exclusives, and also we worked with HTK 3D lab technician
Joachim Harrison.
Thank you. So the proposal that we gave to Planet City, it was a very tight, kind of short time frame, was based off work that was already partially developed through my PhD and then developed in collaboration with these two. And so we had these kind of proposed ideas, and we had a particular kind of colour palette that we wanted to use and way of using patterns, but they were really interested in very, very bold aesthetic, very kind of dramatic forms and very dramatic colours. And so this is what the end result was. So this was designed on Clo 3D as proposed kind of outcomes, and we were looking at combining the methods from the previous project that we showed you, but incorporating surface textile in the woven form, and obviously colour, and really pushing silhouette a little bit further. So all of these were proposed to be zero waste, whole garment woven with minimal seams.
So the surface patterns that you can see at the bottom, that's kind of informing some of the colour choices, they came from the Planet City group, so Liam Young, and they're actually AI-generated patterns. So that was really exciting to work with as well. And we manipulated those a lot in terms of colour and things. So it really was a collaboration.
Yeah. And then the process of development went something like this for every example. There were 3 looks and 4 garments that were developed. So there was a moulding process.
Yes.
With clay, scanned, import into Clo 3D, and then a manipulation of that base whole garment weaving pattern or form that took place in Clo 3D.
And I'd just like to point out that this all happened over April, May and June. So we were physically separated because we were all working remotely. So we did a lot of talking over Zoom.
Yep.
Lots of spontaneous Zoom conversations. You can see Karin in the little Zoom window on the right.
Actually cooking at the same time. I'm in my kitchen. Yes.
So that kind of informed some of the way that these things turned out, because we would have done things differently, no doubt, if we'd been able to collaborate in person.
Yeah, and it also meant that we couldn't sample So we couldn't go to the weaving mill and test the stuff out with them, with their looms. We had to sort of guess a lot. Same with colour. The exact colour choices were a complete guess because you're working over a screen, and so not everyone's screen is calibrated the same. So that was really complex.
And we were meant to be sent colour swatches, but they got lost in the post.
Yeah.
So we had no idea.
Yeah.
What,
So
you know, what yarn colour we choose, etc.
Yeah. So the coronavirus situation made things a little bit more complex than it would have otherwise been. But what you can see here is the coat cape thing, which is on the top left is the map of bindings, and so that's the structural bindings that make the basic 3D form. Below that is the surface pattern, and those two things were combined by Kathryn to make a weavable file.
Lovely work.
Yeah, so I guess, as Holly said, the map of bindings at the top is all about what the layers are doing, while the surface pattern is about what the colours are doing. And so what happens when you combine the two is it becomes very complex, because every layer needs to be carefully separated, but you need to know where each weft and each warp is at all times throughout the garment, because if you miscross one, layers won't separate and the garment won't work. So it's a very different process than weaving your conventional flat fabric, which, you know, and it surprised me, this particular garment had about 50 different individual weave bindings that had to be programmed, but first they had to all be worked out. So there was this real process of actually getting to the point of being able to weave this, which was a lot more time consuming than I expected, certainly.
Yeah. The middle image shows the fabric as it's been cut, and so this is what makes the blue cape coat thing that you see hanging there, and next to it is the mould that it was fitted to. These are the trousers, so same kind of process occurred here, where we had a basic kind of starting form that you can see on the top left, a mould in 3D, and then an adaptation of the design to fit that, and then it kind of trying to visualise how it shrinks over the form. You have a map of bindings and the surface pattern down the bottom left, how that appears in 3D, and then the actual garment outcome. And here you can see it on the loom at EE Exclusives as it's being woven.
Because the trousers are relatively narrow, we were able to weave 3 of them side by side, so it was 0 waste. That was quite a big thing for this project, is to make sure that we're not generating any excess waste. So we were also got a chance to test different styles and ways of manipulating the pattern.
Yeah, so you can see 3 different surface patterns for the same form. This is the dress, and so again you see the 3D form. There's a 3D digital visualization of that in some kind of context. The map of bindings at the centre top, and the surface pattern below that, and then the fabric off the loom about to be cut. This is the tunic, which used the same mould as the first experiment that we showed you, the white dress, but used a slightly different pattern. So we were experimenting with how we used a symmetrical pattern for this one on an asymmetrical mould, and how did that kind of impact the resulting form. And some, really interesting use of combining innovative bindings with colour, and it kind of expands out in a really interesting way.
If we just go back, if we look at the map of bindings, it's actually 2 woven at the same time, one sitting on top of each other. So that green section, they actually overlap, and that's to create a high neckline. And the reason we weave 2 again is so that we don't create any waste. Otherwise, to cut off that area would create waste. So we actually got to keep one, which was nice.
Yeah, because all the rest of them have been sent off to the director. So these are the outcomes and some detailed shots of what that looks like. It's the tunic, the coat. You can see in the sleeve compared to these other areas, there's a really big difference in the way that the yarn shrinks and the fabric behaviour and expression changes. Trousers, gown. And then I guess ongoing work that we have is to develop these processes into other expressions. So these are using the same mould as the trouser that we showed you, but with a different map of bindings, and it will result in a different outcome. So you can reuse like the permanent parts of the process, like the mould, but have very different aesthetic outcomes depending on what the map of bindings is that you use to form on that. And so this is, yeah, weaving it maybe next week. We'll see how it goes.
Ultimately, I mean, I think the vision we have of this is that in some ways it's offering a completely different model to the conventional fashion industry. So these garments are something that you can produce in a local microfactory. As I said, they're zero waste and adaptable. So it's a completely different way of thinking about garments, about textile forms, about fashion.
Yeah. So these trousers, for example, the first pair that we made as a test, we put them on Karin, and the mould, the degree that they'd been shrunken on the mould was too big for her, and so we shrunk them on her to change the size so that it fit her exactly. And you can do the same with any of these pieces. They can be transformed at any point in their life cycle. The other really important thing to note is that these are 100% polyester, so are completely circular with the right processes. The NSK yarn is polyester, the weft is all polyester, and the warp is all polyester, and there's no stitching. The only additional things that have been added are zips. For these trousers, you require to sew in one 18cm zip, and that's the only construction that you do. So they come off the loom, you cut 3 seams and sew in one zip, and they're finished. The dress,
also, they don't unravel, which I think is important. There's no hemming.
Yeah.
There's none of this sort of after
no
work that you have to do.
This dress has the most seams out of all of them. It has a total of 5, but for a form that is this kind of dramatic, the skirt, for example, the circumference of the hem of the skirt is 9 meters. And only required 5 seams to sew the whole thing, because all of that form is woven into the structure itself, and then separated and cut out.
And we got all of that out of a 1.5 by 1.5 metre square of fabric. So it's, you know, it's a completely different approach.
Yeah. So this dress has 5 seams. It has side seams, 2 side seams, and 2 shoulder seams, and a centre back seam. Normally with a dress like this, I don't even
no, the amount of panels you cut and the amount of waste cutting those panels would create, you know, from a
you'd probably use 9 meters of fabric, instead of 1.5. This coat required 2 seams to construct a coat. The pocket, there's a pocket there. It's completely embedded in the weaving. There's no you don't need to sew that pocket at all, you just cut it.
And we could have potentially done that without the centre back seam if we'd done it in more layers on the loom. And the only reason we didn't was to make sure that we could do the patterning that was required for the Planet City project.
Yeah.
So that's actually something we want to look at, is can we weave this in one piece, in one go?
And no seams.
Yeah, because I guess when we've been doing work, often we're quite happy with the pattern that is embedded in the weave bindings. For me, often that is enough drama, but it's I mean, I'm very happy we learned that it was a possibility for placement print, and also again to think about zero waste. I mean, anyone who's ever tried to, you know, match a pattern, you know, a repeat pattern, knows how much more waste you create from trying to get the right print on a repeat. And here it's just woven and you know, embedded into the garment.
You don't have to match anything.
No.
This one required 3 seams. So the sleeves are completely embedded into it. All of the form is embedded into it. yeah, it's actually a very simple process once you have it woven. And when it's being woven, the first time I wove one of these garments, it felt like I was watching yarn being 3D printed. That's the kind of the visceral experience of it. It's like it's been 3D printed in textiles.
In some ways, it is. I mean,
yeah,
that
it's additive.
Yeah, as an extrusion printer. I mean, similar how to knitwear is often, you know, the parallels between knitwear and 3D printing. You see it here as well.
Yeah. I think that's a good point, because knitwear is often, you can make fully fashioned or whole garment knitted. That's kind of been around for a while now, but whole garment weaving, which is what this is, or one term for this, is something that's quite rare. It's been done a few times by a few small-scale production, often done by hand.
Yeah.
Or there's a couple of projects in various research institutions that have been done. But this, we're really kind of pushing what you can do if you weave a garment.
Mm. Yeah, most of the examples of 3D woven garments are quite kind of rectangular because the warp and the weft yarns require a certain degree of adherence to that system. But with the jacquard loom, it's quite straightforward. I also want to point out that this isn't using any new technology. Like, there's nothing new about, we haven't invented a loom, or
no.
Like, we're just using very standard equipment to do this. It's the way it's put together.
Yeah,
that's
just
innovative.
Rethinking where we place technology. Where do we want to place it within the process? So something, you know, like Clo 3D that is generally put to generate a flat pattern on paper or card to be cut and assembled, you know, we're placing it elsewhere in the process, making it do other things.
Yeah, making it make and design the fabric itself.
I think it's a really good point, because what it means is that 90% of the work actually happens before you even start making anything. As Holly said, there's very few seams, and we could potentially redesign them to have even fewer seams. And so you spend a lot of time doing design and getting all that right, but then once it goes to the loom, it gets woven, you cut a few bits, and we're potentially looking at whether or not you could use a laser cutter, a CNC laser cutter to do that cutting, and then you have a garment.
Yeah.
So you don't have ranks of people sitting at sewing machines.
I guess it's sort of reversed to how cut and assemble goes. Like, with cut and assemble, you invest a lot of craftsmanship at the assembly, at the weaving the cloth or knitting it, cutting it, putting it together. Whereas here, we invest the craft knowledge at the beginning of the process on, you know, what to weave, how to weave it, how to cut it up,
yeah.
how to sort of activate the three-dimensionality of the garment. So I guess it's a way, because often when you talk about 3D print, people sort of imagine that you press a button and a 3D printed garment comes out. But I think one has to rethink the process. I mean, we use 3D print. In the trouser mold you saw is actually 3D printed. So you could say, you know, we use 3D print technique to make these garments, but we don't make it for the final outcome. We weave, if you want to call it a final outcome, but, you know, we weave the garment. Yet 3D print technology is
directly informs the whole process. Yeah. Are there any questions from people?
Yes. Is it expensive, the whole process?
It can be. It depends. As part of.
May repeat my question.
Oh, okay. The question is it expensive? It depends a little bit. Part of my PhD research was looking at weaving more simple, like normal-looking garments. So a simple pair of trousers, for instance. And I was working with Milou Verwinden, who works at E Exclusives in the Netherlands, and she calculated the cost per unit. And if you were making 500 pairs of trousers, it would cost approximately €10 to both make the fabric and construct them. So that's quite affordable, and that's at a very high-end, expensive boutique weaving mill. But then, you know, you need to rethink how you calculate the cost, because there's a lot of time in terms of design that's invested at the start. So it's not like a straightforward swap. And I think ongoing, that's something that I'm really interested in researching and kind of working out a little bit more clearly. How do you measure this? How do you calculate its cost? And yeah, so it can be cheap. I would say that these garments, because they're so unique, one of a kind, would be quite expensive. They're not like a, I mean, they're kind of like a kind of couture or something, like it's something else, but with more simple garments, it's quite straightforward.
I mean, there was a lot of programming that went into them that's essentially not going to be reused because of the combination of pattern and garment form. So from that point of view, yeah, couture is, I think, a really good comparison. I think we talking about expensive in relation to clothing is very complicated because there's a lot of external costs that we don't consider when pricing garments. If you go out and buy a pair of pants from H&M, you know, there's a lot that doesn't get included in that. Environmental costs, for example, social costs. So one of the things that we're really interested in as the Critical Textile Topologies Collective is, you know, what can we do to work around those costs? And what can we do to kind of make the whole system better?
Yeah, it's attempting to change the entire system. So calculating cost is part of that, and I think it requires a very different approach to conventional cut and assemble garments.
And I quite like I mean, it's slightly rebellious because this you can't fit into a cut and assembly system.
No.
So it's not like nobody can sort of hijack this idea and just start mass producing, you know, under bad, you know, sort of really bad living standards, etc. This, you have to rethink your whole production if you're going to adapt this idea. So only, you know, companies that would be
really invested in it.
And ready to do so, to scrap what they've done before and start anew with a new process, a new system,
new way of thinking.
Yeah.
Any other questions?
I have a question, and I think Stefan has a question too. So I'm going to start here.
I've been listening to you. It's very impressive. And you said it's not new several times, but I wonder if this is not a revolution.
Well, I mean, the individual parts of the system exist. So the machinery exists, the software exists. What is new is the way of thinking, the design thinking. Yeah, and so it's I mean, yes, it is new, absolutely. But what I meant is that the different parts of it doesn't require investment in new technology. It doesn't require that we invent something new. We have what we need now to have this revolution.
But you can change the whole thinking of sustainability. Yes.
Yeah.
It's impressive.
Stefan, do you have a question?
Yeah. I think this is quite amazing, actually. I know that we did a notice, we did a pattern search on this. What you say, what's new and not. And what came out was that the different parts are not new, but there are some aspects of this put together that is new, that you can actually protect. So keep that in mind.
Yeah.
But my question really was, this. I think this is quite amazing because it's not just from the sustainability standpoint, but because it's fast. And if you can multiply it and say, industrialize it, it could be rather cheap.
It could be.
Yeah, because it needs.
Okay. Sorry, I should have kept it. Or swallow it.
What I said was, you're talking about microfactories. Do you see any further use of this, like multiplying or industrializing it?
I think I'm really concerned with the impact of scaling up. I think in most cases in all industries, but particularly in the fashion and textile industry, gains that we've made in terms of sustainability and circularity, etc., better use of materials, have been all the positive gains of that have been eroded by growth. So we have, I think we have a responsibility to be very, very careful about what we kind of propose to expand and grow. I think overall we need a reduction in production of new materials. I think all of the new production we do going forward needs to be, I guess, this kind of thing, where it's like super local, made local to where it's people want it, so local to Sweden or the UK or Cambodia or wherever it is that you are. Everywhere. It can work anywhere, and then you need to ensure that so all of the new production is as ethical and low impact as it possibly can be, and only on demand. Like we.
Don't you think your idea is very suited to that?
Yes, yes,
because
I do.
As you show, no cutting, no sewing.
Yeah.
I guess the point is that we kind of reject the whole concept of industrialisation and mass production. We would, in many ways, would hate to see this being taken into mass production, because it would undo a lot of the work that we think is kind of the thinking behind it, and that we would like to see hyperlocal, microfactory-based production, production on demand. You know, there's a lot of garments that never get worn that get sent to developing countries, and that undermines their own textile and garment production. Yeah. So if we didn't have all that waste, they could build much better industries for themselves. Yeah. So there's a whole. We're very conscious of this big picture, this systemic view.
But you've given a suggestion for a very good business model now. What you say?
Yeah.
And this is very well suited to that.
Yeah, it is. I think the moving all-fashion production to on-demand, localised, of semi-automated or fully automated is got to be the way that we head for our future. It's completely radical. I'm really fully aware that it's like nothing like what the industry is currently. I mean, the fashion industry employs more people than almost any other industry on the planet, because making garments uses people's hands. Yep. Like it's a very manual labour intensive process, and this really upends that. So I think all of our new production needs to be this kind of thing. Not only this, but whole garment knitting, for instance, fits in with this model extremely well. As 3D printing develops, I think that fits into this extremely well. And then I guess everything else needs to be recycled, upcycled, using existing materials that we have. And this system could use existing materials in a circular kind of approach as well.
I think it's great. But then again, all the things you showed us now, the garments you showed us, they are rather special, futuristic.
Yeah.
Not anything you would wear.
No. But I mean, my PhD will be out in a few months, and in that you can see an ordinary T-shirt and a very standard pair of trousers.
That was what I was going to ask you. Can you make a jacket?
Yeah. I can make very ordinary looking garments.
But then I guess also, I mean, from an artistic perspective, we're also interested. Because what you say, a lot of people say, can you make this? But then it's also what we're interested in is the aesthetic that stems from another way of thinking of form. The reason your jacket looks like that, it's because it's been cut and assembled from a flat surface into having three-dimensional form. And there's certain rules and certain tools that makes your jacket look like that. Yeah. If you have a completely revolutionary way of making dress, why would you want that suit jacket? You already cut and assemble makes that jacket to perfection. So just go and get a really well-made cut and assembled suit jacket at the tailor's, and then choose something else that isn't in your wardrobe, that's made in a different way. Sorry?
If you can mold on me.
Yeah, of course I can.
One shape.
Yeah, I'll 3D scan you anytime. for free. Yeah, trying to like step out of capitalism.
Choose the colors.
Yeah, you can choose the colours.
Yeah.
Yeah.
I'll do that.
And I think that is also one of the things with this, that we want to present this, you know, garments can look in a different way. Because just like you, I also made a non-woven T-shirt to sort of, you know, proof of concept. Look, I can do this and I can make a T-shirt. Like everybody wants a T-shirt, don't they? And this T-shirt is zero waste, etc. But then we really discussed this and rethought this, because it has somehow to come from an aesthetic viewpoint as well. What can we offer that is different? Because if we can't offer something that is different, me personally, even though I work away from cut and assemble, I'd rather go to a tailor and get a really nice tailored suit jacket if it's a suit jacket I'm after. Because cut and assemble makes beautiful suit jackets. You know, and if it's crafted by a tailor with, you know, in a cloth that was sustainably sourced, it's not that, you know, necessarily that unsustainable. And it will probably last me for 35, 40 years, because I won't wear it every day unless, you know, I completely wobble out. But yeah, so there's also that thought of, you know, what do you want to put out there? What do you want people to come to you for, so to speak?
Yeah. The interesting thing about what we expect garments to look like is that we kind of take them for granted a lot. Like, we don't really think so much about why the garments that we see all around us every day look the way they do. And it comes out of a model that was developed at a time when we didn't realise the impact of our decisions.
Yep.
That the negative impact that they would have on the environment and on people. It was built at a time when we thought Earth's capacity was limitless, you know, and now we know that's not true, but we still use all of those methods. We still have that way of thinking, and the aesthetics that came out of those processes of production and those business models are still kind of like a baseline that everybody will compare everything else to.
Yeah.
And so we, like, you know, in Karin's PhD and in my PhD, we both went, yes, I can do a T-shirt, yes, I can do a pair of trousers, of course I can. But then you go, well, but what else? So what? You know, and so then it becomes, you know, what else can we do? What other kind of exciting futures can we visualize for people and go, you know, this is what we could be wearing.
Yeah.
This is how we could be making this stuff. This is how we could be thinking. That's different.
Like designers.
Yeah. Absolutely.
But
well,
also,
we can't help that.
I mean, what
Well, you have to awareness. It's quite amazing.
Thank you.
Please use it. Please let it live on beyond your PhD.
Yeah. Well, that's the plan.
Yeah, but I mean, okay, so I find this discussion really interesting, so I have to just continue it for one more minute. What I think is important, and what I think a lot of people don't sort of reflect upon, is that most clothes that we put into an industrial, you know, production system, they've already been conceived through, you know, through craftsmanship, like the tailored jacket. I think, you know, the trouser, like two legs that actually joined with a seam, I think that was invented in the 13th century or something. And then obviously clothing production was not unsustainable, you know. It was home seamstresses, the local tailor, you went there, you got, you know, if you were rich, you went there, you got measured, you got your suit. If you were not, you know, you bought a tiny bit of cloth and you made yourself a dress, and when that couldn't be mended anymore, you made your baby a pair of trousers from the pieces of cloth that was there. But once industrialization took over, we put that way of making into a mass, you know, a system of mass production. It wasn't made for that. Most garments weren't made for that.
Yeah, and as a result, we end up with, you know, an industry average of between 15 and 25% waste from cut and assemble, of which 10% is recycled. So it's like, it's a completely incompatible way of making garments in the context of mass production. And, you know, that's why we have the world we have now.
So it's mainly the system that doesn't work. To you know, to order a dress that is made through cut and assemble isn't possibly the worst thing you can do. It's when you put it into the type of system and scale that we have today that it becomes a major problem.
Okay.
All right. Nice talking to you. Thank you very much.
Thank you, Stefan. Hörs jag här? Bakom, nu pratar jag lite svenska. Bakom er så står det ett ord där det står
en seminarium här igår som handlade just om att utmana tankar, challenge your thoughts. Because this is about, it's just not the dress and the design, it's to challenge your thoughts, the whole rethinking.
Yeah.
Yes, I'm very impressed. Thank you so very much for coming.
Thank you.
And good luck.
Thank you.
Thank you.
Thank you.
Då så gör vi lite paus. Vi gör paus i en kvart och så kommer Gunilla tillbaka och pratar om Samordningsförbundet och innovativ rehabiliteringstänkande. Så välkommen tillbaka om 15.